Worldwide. You everybody, every.
Welcome to completing the square. Alright, so this is a new method that we talked about for solving quadratic equations. Alright, as you can see here, we've got 7x squared plus 14x plus 3 equals 0. Not factorable, not super easy to graph, and besides we want to use a different method. So we're going to do this thing called completing the square. The first thing I'm going to do is I'm going to work to get the coefficient in front of the x squared, the leading coefficient, to 1. It's going to make completing the square a heck of a lot easier. So what I'm going to do here is divide by 7. So I divide that function by 7, and we talked in class about why that's a legal move. So think to yourself, why can't I divide the whole thing by 7? So we're looking at this. We've got x squared plus 2x plus 3/7 equals 0. The next step that we're going to need to do is kind of give ourselves a space to complete the square. And I'm going to do that by subtracting 3/7 from each side. So I've done that. Now I'm left with x squared plus 2x plus blank, we'll get to the blank, equals negative 3/7. Let's look at what's actually happening here. We can do this with lab gear actually. So we're going to look at our lab gear. Here we are with our function. Obviously the area representing our function, and we're going to try and put this together, turn this into a square. Again, we've got our x squared plus 2x, which is what we see over here, x squared plus 2x, and we've got to complete the square. This little area right here has got to happen right here. And obviously we can see 2x adding 1 unit completes that square. So I can add 1 obviously to the square to complete it, and then it becomes fairly easy to visualize our binomial here that gets squared, which is x plus 1, and I'll actually write that in. So we've got x and then plus 1 times x plus 1. All right, or x plus 1 squared. That's the whole point. So again, to reiterate, what we're really looking at is we're setting x squared plus 2x plus, in this instance 1 equal to negative 3/7. Okay? But again, we've got to add that 1 in. All right, and that's going to happen in our next step. All right? And I actually really like writing out the equation, getting to this point and leaving that little blank right there, so that I'm thinking, okay, what's going to complete the square? And then I know whatever I add to it here to complete the square, I have to add it to both sides. Then I'm thinking about, okay, my perfect square binomial, which, as we said before, was x plus 1 times x plus 1. Okay? So I know that I can re-express this term here on the left as a perfect square, x plus 1 squared, and I've added my 1 to negative 3/7 to get us 4/7. Then I just solve using the equal square method we talked about earlier. So what am I going to do? Think about it. Got 2 equal squares. So I'm going to square root both sides of the equation. Okay, so I'm going to take the square root of both sides of the equation, which leaves me with x plus 1 equals plus or minus, because we're taking the square root of it, 4/7. Solving then gives us x equals plus or minus the square root of 4/7 minus 1, and then that'll be up to you to simplify the square root of 4/7. So again, to rehash, completing the square. First step is to eliminate the coefficient in front of the x squared. That's going to make completing the square here a whole lot easier. The next step is to find out what completes the square. And a side note that we talked about in class was, sometimes it won't be as obvious as x squared plus 2x plus 1. However, that you can always find this term right here in red, by dividing b, this coefficient here, dividing b by 2 and squaring it. And that's a great way for finding the necessary value for completing the square. All right, so we complete the square, we rewrite it as a square binomial, we take the square root of each side, solving by equal squares, and finally we solve for x. Go ahead and practice some on your own. This is off page 16 of your quadratic equations packet.